Okay, the 4.7 task gets into graphing sine and cosine curves that have several manipulations in them. So yesterday in class we talked about basic versions or generic versions of the curves that look like this, where the A value in the front was your vertical stretch known as amplitude. Your B value in the center is your angular speed. That's also considered your horizontal stretch or shrink. The D value on the end is your vertical shift, also known as the midline. And then this C value is called the phase shift, also known as your horizontal shift. Cosine's equations in basic form look very similar. And all the variables represent the exact same things. The only difference between sine and cosine is that they start their graphs in different places. So if we take this first equation and we want to identify all the important features, the negative in the front is a reflection, but my amplitude is still a value of 1. So I'm going to identify that as 1, and then I'm also going to make a note that there's an x-axis reflection. Just means that the curve is going to be upside down. If I want to figure out my period, it's always, in this case, all of my stuff is labeled in radians. So we're going to go 2 pi over my b value. In this case, 2 pi divided by 2, which gives me a full period length of pi. Phase shift, there's nothing with the x, which means that there is not one. And my midline value is that vertical shift value on the end, which is 3. Since our midline is going to be drawn as a horizontal line, please write it as an equation, y equals 3. So I'm going to come to my graph. I'm going to put my midline on my graph. Since I am graphing a sine curve and there's no phase shift, I know that I'm going to start on the midline at 0. Now, the other day, yesterday in class, we talked about how to figure out the spacing between all of your significant points. We're going to take the period value. We're going to divide it into 4 equal parts. And that tells us the spacing for every single one of our significant points. So every pi over 4, we're going to have maximums, midline intersections, and minimum values for our sine curve. So every pi over 4. So that means that with sine, we would normally go up the amplitude. Since we have an x-axis reflection, we're going to go down the amplitude. So my first dot is going to be down. Then we're going to hit the midline. We're going to have a maximum, and we're going to hit the midline. The reason why the dots are so closely spaced in this one is because the cycle length, the period length, is only pi, which is half of its normal period length. Now, the deal with this is that if we connect the dots, that represents 1 period. I want 2 periods. That second period can either be added on the right side or the left side. It does not matter which one. I'm going to add it on both so that you can see what it would look like on both sides. All we're doing is continuing on the same pattern that we just had. So that's 1 extra period added. This would be sufficient on your quiz for 2 periods. But we're also going to add one on the left side here so that you can see that if you had added it on the left side, what that would have looked like. Okay, one of the things I'm going to talk about here is my pet peeve. Sine and cosine curves go on forever, which means we need to show that by putting arrows on the end. Please don't just stop at the end points and think that that's all that's graphed. If you stop at the end points on your quiz, you are going to miss half a point for that. So please show that there are arrows on each side showing that the curve does continue. For domain and range, this is never going to stop going left and right, which is why our domain is all real numbers. So interval notation is fine, as is symbol notation. The range, we're bouncing back and forth between 2 numbers. Those numbers are 2 and 4. And since we actually get to both, we use inclusive brackets. So there is a version of a sine curve with a different period length. The next problem is another sine curve. This time we introduce an amplitude change, a period change, and a midline change. All of those things are things we've talked about previously, so I'm not going to do this example. Instead, we're going to move on to do a cosine example in which those things are happening. So what we want to do first, just like with a sine curve, is identify all of these things. My amplitude here in the front is 3. My period length is going to be 2 pi divided by my b value, which gives me a period length of pi over 2. That in essence means that the cycle is going 4 times as fast, or you can think of it as the cycle length is 1/4 its normal length. The phase shift, there isn't one again in this one because there's nothing here with the x. And then that -2 on the end is a midline change, y equals -2. First thing I'm going to do on my graph is put my midline change of -2 on the graph. And please do that also on your quiz. Next thing I want to do is identify where this period should start. Since there is no phase shift, we're going to be on the y-axis, but cosine starts 3 units above its midline. So we're going to start up at +1. Now to figure out spacing, we're going to take our period length, divide it into 4 pieces, and that means that we are going to go by 1/8 of a pi for every single one of our significant points. Since the x-axis is marked off in pi/4s, that means our pi/8s are going to be halfway in between. So this period is going to be very condensed down. So we're going to go from that maximum value, we're going to go to the midline. Then we're going to go down 3 units to a minimum value. Then we're going to hit our midline again, and then we're going to finish at a maximum value. So if I connect just those pieces, you can see that I finished 1 full cycle of my cosine curve in pi/2, just like it said I needed to. The next thing you want to do is add that second period either to the right or the left. It doesn't matter which. I'm going to do both so that you can see what both sides would look like. We're just going to continue the exact same pattern. Again, like I said in the last problem, showing that it does continue on that side. If I continue it on the left side, it's the exact same pattern. We're just working it backwards. And so what I end up with is the exact same curve drawn on both sides. Now we move on to what does it look like to have a phase shift, and what does it look like to have a b value that has been multiplied in. So number 4 here, I'm actually going to skip for right now and come back to it in a second, and we're going to talk about number 5. Do I want to do 5? Nope, I changed my mind. We're going to do number 4 next. So cosine curve, the only thing that we need to focus on here is that we've got a b value that's been multiplied into the parenthesis. So anytime you have something where there's a bx there, like that, you have to take this b value and you have to factor it out. So since this is x/2, that's a 1/2 that's in there. So we're actually going to rewrite this equation as y equals 3/2 cosine. That 1/2 is going to be factored out of the parentheses, which leaves just an x. When I pull a 1/2 out of this, that's like dividing by 1/2, which is the same thing as multiplying by 2. So you're actually shifting to the right by 2 pi. If I go about identifying all of my main feature points, amplitude in the front is 3/2. My period length, 2 pi divided by my b, so 2 pi divided by 1/2 is actually a period length of 4 pi. Phase shift, I want to include direction with this. Since it's -2 pi, we're moving to the right by 2 pi. And then my midline, I've got a vertical shift of 1, so my midline is y equals 1. Now the problem with the way my graph is scaled is that my period is the entire graph, and I'm starting to the right by 2 pi, which means I'm starting way over here and then continuing on. It's not really going to fit. So what I'm going to do is change the scaling on my graph here so that everything fits better. I'm just going to make all of these go by pi. So that means that's pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on. And we'd want to do the exact same thing on the other side. So we've got a -pi, a -2 pi, and so on. The scales on your graphs on your quiz will be given. If they're not, you will have to scale your own graph. If you don't like the scale that your graph is scaled at, you can always change the scale. Just make sure that you note it like I did on mine. So a couple of things about this. Number 1, midline is going to be up at 1. My amplitude value is 3/2, so that's 1.5, and this is a cosine curve. So that means that we are going to start above the midline. The deal is, though, where my phase shift is where my period starts. So I'm going to start at 2 pi instead of starting on the y-axis. So from my midline, I'm going to go up 1.5 spaces. So the first dot of my period is going to start there. If I want to figure out the spacing for all of my significant points, we're going to cut my period into 4 parts, which means they're all going to be a spacing of pi from each other. So I'll go to the next one, and I'll have a midline intersection. Go to the right one more, we'll go down 1.5 for a minimum. Go to the right one more, we'll be back on the midline. Go to the right one more, and we'll be up 1.5. So I end up with a first full period that looks like that. If you want to continue on to the right, you can. The problem is you're going to run out of room. So I'm actually just going to show that that tail end goes there, and I'm going to finish my second period off to the left, doing the exact same pattern. So midline here, down 1.5 units to a minimum on the y-axis. To the right on the midline again, on the left, and then to the left one more, up 1.5 units. And so what I get is a mirror image of the exact curve that we just drew before. Domain and range, again, domain, all real numbers. Feel free to use interval or symbolic notation. Range, we're bouncing back and forth between 2 values. The bottom value down here is -1/2, and the top value up here is 2.5. Important thing to recognize about this is that that b value was multiplied in. If it is, you do have to factor it out. Otherwise, you're going to identify your phase shift as the wrong value. We've done a couple of cosine equations in a row, so let's do, looks like they're all cosine. Let's change number 5 here. Instead of doing this as cosine, let's do it as sine instead. So just a slight change. Let's write that as sine instead. Notice here the b value is not multiplied in. This is a little small, so I'm going to rewrite this so it's bigger. For those that are watching this on a cell phone, this will hopefully be a little clearer with it written a little bit bigger. So I didn't change anything other than I just wrote it bigger. So let's identify all of our main feature things. So number 1, amplitude is 2. Also making note that there's an x-axis reflection here. The period length. Now this one's a little different. So 2 pi, and we're dividing by pi over 4. If I simplify that correctly, I get a period at length of 8. Phase shift is going to be to the left by 1. And the midline value, there is no change, so it's y = 0. In other words, it's the x-axis. So, first thing I want to recognize about this so what you want to notice about this is that I've got no scaling on my x-axis, which means that I need to scale this myself. So you can scale it however you want. If you want to scale it by 1s, that's fine. If you want to scale it by 2s, that's fine. I'm just going to scale mine by 1s. And so all I'm going to do is show that every other one of these is an even number. So I can clearly see that my scaling is by 1s. And I'm going to do it to both sides. If you run into a problem on your quiz in which the scale is not done for you, you're going to need to scale it for yourself. Also showing here that you want to scale your y's by 1s, that's fine. So again, I'm not doing every one of them, I'm just marking every other, so it's very clear what my scale is going by. So I need to figure out where my first point would be for my sine curve. Sine always starts on the midline, so we're going to start on the x-axis. We're going to start it to the left by 1 unit. So we're going to start right here to the left by 1. If I want to figure out my spacing, I'm still taking my period and dividing it into 4 pieces, which means my main feature points are going to be every 2 units. This is a sine curve with a negative leading coefficient, which means that instead of going up like normal, we're going to go down. And we're going to go 2 spaces and then go down 2 spaces. 2 more spaces back to the midline. 2 more spaces up 2 units. 2 more spaces back to the midline. And so what this gives me is a sine curve that is upside down from normal because it has a negative leading coefficient. Now we'd want to add a second period, so a second period won't fit to the right, so I'm going to add it to the left. We're just going to work the exact same pattern. We're going to work it backwards. So 2 units and up, 2 units midline, 2 units down, and 2 units midline. And so what I end up with, again, is a mirror image of the exact same curve. This over here, notice how I left that as an endpoint. We would want to show that that continues with an arrow. Don't miss that half a point on your quiz. Domain, all real numbers. Again, use interval or symbolic, I don't care. And then my range, what am I bouncing back and forth between? Those values are -2 and +2. We are going to skip number 6. Let's go to number 8. So again, it's a little fuzzy there on the, so I'm just going to rewrite it above here so it's a little clearer. So this says y equals 4 sine of 2x plus pi over 2 minus 1. So it's a little bit clearer. So this again brings up the issue where I've got my b value that has multiplied into the parentheses. We don't want that there. What we want to do is we want to factor it out of both of these. So I'm going to rewrite this equation with it factored out. If you don't factor it out, you're going to identify your phase shift incorrectly. So you have to factor it out, remembering that when you take it out, you're taking it out of both of these. So I have to divide this by 2 also, which is going to make my phase shift left by pi over 4 instead of pi over 2. If you don't do that, you're going to identify your phase shift incorrectly. You have to take the 2 out. Now when I identify all of my main feature points, we are going to identify in the front, my amplitude is 4. My period length, 2 pi over my b value, which is 2. So it's pi. Phase shift, we are left by pi over 4. And my midline, we are down 1. So y equals -1. First thing I'm going to do is put my midline on the graph at -1. Remember, the phase shift here is what tells you where your period starts. So I'm going to move left by pi over 4, and that is going to be the first place I put a dot for sine, and sine always starts on its midline. Whether it goes up from there or goes down from there depends on whether the a value in the front was positive or negative. Since it's positive, that means my first movement is going to be to go up. If I want to figure out the spacing for all of my important points, we're going to take and divide the period into 4 pieces, which means every significant important point is going to be every pi over 4. So we're going to space everything out by pi over 4. My amplitude value is going to take me up 4 units. Then I'm going to come back down to the midline. Then I'm going to go down 4 units. And then I'm going to finish on my midline. So those points are going to give me 1 period. Now, since this one does have room to add it on the right, you can add it to the right. There's also room on the left. Since I've been adding things on the left most of the time, I'm going to add this one on the right. So we're going to go up the amplitude on the midline, down the amplitude, and on the midline. And we'll finish our second period. Again, showing arrows on either side to show that the graph would continue beyond what's being graphed. Domain and range, again, either symbolic notation or interval is fine with me. Range, what am I bouncing back and forth between? We're bottoming out here at -5 and we're topping out at 3. So we have a range of -5 to 3. There are a few more examples in here, but we've done, I think, enough examples that I am going to end the video having done those.